So I've shown you how to use a pin set in output mode to control an LED. Now let's look at how to use a pin set in input mode to read a value from this limit switch. This limit switch has a little metal arm with a little micro switch there, and as you can see, I can press it up and down and it makes a very satisfying click and it feels really good. The important thing to understand about the limit switch is these two leads are electrically isolated when I'm not pressing it down, and as soon as I press the button down, they are electrically connected. What we're going to do is we're going to have one side of this connected to pin number 8, and that pin is going to be an input pin, so it's going to be sort of listening to see, is there voltage or is there not voltage? And the other side is going to be connected to positive voltage. So as long as these two aren't electrically connected, my pin number 8 won't read that there's any voltage because there is no circuit there. But as soon as I complete the circuit and there is voltage all the way through, then my pin will read that there's voltage and it will register that. And in a second, we'll use that to control the LED. So let's hook it up. I'm just going to attach it on 2 random rows here. And as I said before, I want one side of this to be connected to my 5-volt voltage source. So this positive rail is still positive voltage. So I'm going to connect this side to the voltage source. My other side, I'm going to connect to ground. So that means as soon as I press this button, it will complete a circuit because current can flow from my positive voltage through this row, through the switch, and then complete the circuit by flowing out to ground. But I'm going to do something else. Actually, here, let me do this. I'm going to actually use a resistor to connect the other lead from my switch to ground, and I'll tell you why in a second. This is called a pull-down resistor. On the other side of this, I'm going to connect in this same row, the same row that's connected to ground through the resistor. I'm going to connect that to pin 8. Here's the idea. I want my pin number 8 to actually measure that there's voltage right here. What would happen if the resistor wasn't here? What would happen if I just had a wire connecting this to ground? Remember, voltage is kind of like pressure, like water pressure in our water analogy. So if there was no resistance that would resist the water flowing straight to ground, there wouldn't be any pressure at this point because all of the water would just be flowing directly out. So actually, without this resistor here, I wouldn't measure any voltage at this point at all. So this is a 10 kilo ohm resistor, which is a high enough resistance that when I press this down, it's going to provide resistance that will allow my pin number 8 to read that there's voltage here. Let's write the code that lets it do this. This is my program from a second ago. Let's comment out some of these lines because I actually don't want to look at the LED while I'm testing this other part. And we'll put in all the elements that are required to read values from an input pin. Remember, you're going to need to do this later for other types of sensors. So don't just follow the instructions, like think about what's going on here. So whenever we do anything that's connected to pins, we have to declare a constant telling us what pin we're going to be dealing with. I'm going to call this button pin, and it's pin number 8. Now here in setup, I'll set pin mode, and I'm setting my button pin to be an input pin because I'm going to be reading values from that pin. Now here inside the loop, if I'm going to be reading values, I need a variable to store the result into. So I'm going to make another integer in here called button state that I'll set to 0. Button state means like, is it on or off? And I'll say my button state equals digital read. All right, before we run this, we don't really have a good way now of seeing whether or not it's reading the button correctly. So I'm going to show you another thing that's extremely useful called the serial monitor. Here, if you type serial.begin 9600, So here, I'm going to say serial.println, and I'm going to print the button state. So as you can tell by the print line, this works sort of like the console. I'm going to go ahead and upload this to the Arduino. In order to check that it's actually working, you want to click on this button up here that says Serial Monitor. You can see that it's streaming out zeros. 0, you remember, means low. It means that there's no voltage measured there. As soon as I press this button and connect the electrical circuit, it should be measuring high, which it's going to display as a 1. So let's see if it works. I press the button and it's 1. I release the button and it's 0. So that shows me that I'm reading the value of the button correctly. And now that that value is in a variable, I can use it to control whatever I want to control. So let's do this. Let's uncomment this line, and I'll say if button state equals high, then I'll turn the LED to be high also. Otherwise, I'll digital write the LED pin to be low. Let's upload this. Now, whenever the button state is high, and remember that happens when I'm pressing the button, it should turn the LED on, otherwise it will turn the LED off. I'll turn the serial monitor on again just so that we can watch and make sure this makes sense. So when I press it, it goes on, and when I release it, it goes off. Which might not seem that exciting. It might seem like, why do we even need to run it through a microcontroller? Like, couldn't we just hook up the electrical connection through the LED to the switch directly? And the answer is yes, you could. But this is just an example. You could hook up anything you wanted other than an LED that's controlled by the button state. I could also have it be the reverse. I could set the button state so that when the button is low, the LED is on, and then as soon as I push down the button and the button state is high, it'll turn the LED off. So now the button is, so now the LED is on, and as soon as I press it, the LED goes off.